We're going to talk about how to mount and a few peculiarities of a ground adjustable propeller. What you want to do before you even unpack the prop or unpack it and look at it is see what you have for the engine. The most popular scenarios would be that you, for a light sport aircraft engine like a Viking or a Rotax, would be that you would have a certain bolt pattern, which is the distance between the prop flange attach hardware. You might or might not have a center nut or protrusion or centering device. If you do, there will be a ring here with a certain diameter. Now if you do, then that ring would be designed to pilot the propeller or the propeller spinner in place for everything to stay concentric. If you have a nut, then the precision machining of the propeller itself onto the propeller lugs would be the centering device of the propeller. Now, 13 millimeter has become like the standard for Rotax and Viking. Check with your particular engine. That's the outside diameter of these lugs. We call these lugs. Most manufacturers make them with a thread inside. These are threaded, hardened, and plated, which is what you want to look for. The internal thread is common to be 8 millimeter. It's referred to as 8.15. What that means is an 8 millimeter diameter and a 1.5 millimeter between each thread, or thread pitch. That's the most common. You can use bolts that are grade 8. That's a metric rating, up to 12.9 rating. We use 12.9 plated hardware, which is somewhat difficult to get, but it's very strong. Now, here's a propeller extension. Sometimes you want to use a propeller extension, sometimes you don't. This one is machined and it would then fit over the propeller lugs. The propeller lugs themselves have an exact diameter 90% of the way in, and then a slightly oversized diameter the last, let's say, 1/8 of an inch or so, which means this would fit almost all the way in, and then it would either have to be tapped or just pulled in with the bolts the last little bit. Now, what you want to do before you even get started is get your hardware and your washer. We're going to talk a little bit about these washers. This is the most modern and common way to attach a propeller without having to safety wire every time. I would say with a wooden propeller you still want to safety wire, or if you have a big crush plate you can get away with these Norlocks if you go back and retorque on a regular basis, because the wood will shrink and expand depending on moisture content of the wood. But for an aluminum propeller, torquing it one time is usually sufficient. The Norlock washer is fairly new design. It's a two-piece washer. When you get it, it's usually kind of stuck together, and then you should just leave it together. If it falls apart, the serrated or the fine serration edges go out on each one, and the large serrations or ramps go together. And the way the washer works is when you torque the bolt against the washer, nothing really happens. But then when you want to back it up, the serrations dig into the metal on both the bolt and the hub of the propeller, and the ramps need to be actually, it needs to unramp, which means it goes up on the top of a ramp and then falls back down, and goes up on top of a ramp and falls back down, which means it physically takes more torque to undo the bolt than it does to tighten the bolt, which is the invention of this washer. And for instance, Whirlwind supplies your prop with these washers, and if you don't have them, you could get them from somewhere, like McMaster Car, for instance. Now, you have your bolt, you have your washer. What I would do, because you want to know for sure everything that you do about your propeller, you need to know 100% for sure that everything goes together the way you think it goes together. Because if not, if the bolt seems to be tight, but it's not really tight, it really just bottomed out on the threads, and you torque it, guess what? The whole thing is loose, Might not seem loose on the ground, but it could get loose, and then you get movement, and before you know it, the whole thing shatters and comes apart in the air. So what I would do is I would tighten this down, or just screw it in. I would find out like when it's flush on the back and see what you have for distance here. Then I would maximize it, turn it all the way in until you're out of threads. Make sure it doesn't hit something on the back against the engine, or that when it goes around that it won't hit something on the engine. And also give it that measurement and write that down. Okay, and then measure what you have on the back here. Okay, this is going to tell you when your final assembly if you are on the thread or almost out of threads, or so forth and so on. Now with the Norlock, you can't just pile washers on here because it takes away the effect of the Norlock. Okay, if you now put 2 or 3 other washers here, they're going to slip against each other, and the Norlock is not working. It's not holding the bolt the way it's supposed to do. Now moving forward on this particular installation, this is a generic, showing generic how to mount and what to be careful about and so forth. But it's very similar for, between the propeller brands and different engines. But it's different enough too that you can get in trouble. This is why I'm trying to point out these little things. So now we just slip this on. This particular installation is designed to have the precision of the machine surfaces to guide everything into center. And also this last little 1/16 or 1/8 of an inch I talked about, when we tighten this down, it goes into an even more precise setup. Here's a spinner bulkhead. Sometimes the spinner bulkhead goes behind the propeller. Like this now becomes our new phase, or propeller flange face, because it's really just an extension. So we move the face from here to here. Now also this design uses the same bolt holding everything together. There are other designs where the propeller extension is now bolted to the engine, and there's another set of bolts that hold the propeller to it. This is of the design where everything uses the same bolts. Now here's a spinner bulkhead again. It's the precision of the CNC machining that makes that a perfect fit. And it is precise enough that you want to, move it in very gradually, all sides equally, because if it's just a little bit canted or tilted, then it locks in place. Now we're ready for an actual propeller. So we're going to leave this area and we're going to go and look at one of the brands of propellers that you can purchase and use. This happens to be a Whirlwind propeller. There are other propeller brands like the Warp Drive and so forth that are very similar in design. A lot of times they'll have 6 bolts inboard, and they're kind of the main bolts that hold the majority of the load, and then they'll have a couple of smaller bolts outboard to support the propeller shank as it leaves the hub. A lot of the new hubs are CNC machines, so they can use a little ball end mill to really sculpture it, take away the material that's not necessary and retain what is necessary. On the back side of this one, we've got a pocket that's machined, usually guides onto some kind of centering ring on the engine, or just gives relief for a nut holding the propeller hub to the gearbox or the engine itself. And then it has pockets for the lugs that stick out of the engine. Those are usually used also as centering devices. Most times a centering lug in the middle and the lugs are not necessary or desirable. You want to pilot on one or the other as far as ease of assembly. You do want to, hey Leo, you do want to make sure that your propeller counter bores back here are deep enough for the lugs that stick out of the engine. Also quite important. So basically just take a ruler or you measure the lugs as they stick out of the propeller, subtract for any kind of spinner bulkhead that will take up some of that gap, and then use anything to stick down in here and put your thumb on it and hold a ruler against it. Or if you have calipers, use calipers. And make sure that the pocket is, at least a 1/16 of an inch or more deeper than what is required. Because the last thing you want is the lug to bottom out and the propeller actually sitting on the lug, which the lug itself is only pressed into the propeller flange, and then the whole propeller would seem tight after tightening down, but as you start running it and the propeller lug starts floating in the propeller hub, everything becomes loose. And so you don't want that. Now, let me flip this over. This is the face that goes against the propeller, the crankshaft, or the gearbox flange, prop flange, or the propeller spacer on the engine. On this side, it's where the bolts are going to be inserted. Now, if it's a wooden propeller, I also know warp drive, even though it's a metal propeller, they require a crush plate. A crush plate distributes the load on this side of the propeller. The Whirlwind does not require that. You just install the bolts from this side, and then they go through your spacer or not, and then into the engine. You torque them down. Here is a little bit different. There's a slightly different system here with the Viking and the Viking spinner, where you would install these steel bushings, little spacers, because in order to get the spinner support, the assembly is just made that way. So then this would go through here. Of course, it's not the easiest thing in the world to line all this at the same time. And then when this is put together, now it's ready for to be transferred from here to the engine. You're going to need some basic tools. Some of them are supplied by the propeller manufacturer and will come with your kit. This little contraption is something we're going to show you how to use. It comes with every Whirlwind propeller. Basically slides over the blade to give you a flat surface from which to measure from. This is a protractor that you would get if you ordered a warp drive propeller. It sits on the front of the reason that one side is, this by the way is a warp drive blade. It's what's called a straight tip, and it does not have the nickel edge on it. So this would sit on the blade with the rigid part, which is the gray part, down like that, and then you tighten up these wing nuts a little bit, and this is slightly flexible. And what it does is when you mount it to the tip of the propeller, it keeps this from wobbling. So that's really what you want, is this to stay stationary against the gray plastic, and the white thing is just to hold it up against it. You don't want to tighten it too much because eventually this thing will crack, but that's how that works. So that's a protractor. Now this protractor is kind of handy. I think it even is available in the Spruce catalog, and it can be used on any propeller. It doesn't have to be from warp drive. If you don't want to use a protractor, or you just don't have one, and you happen to have a smart level, a digital level, you use that. You would use that in combination with this flat paddle, for instance, because it gives you a location where you could put the level parallel up to it, and that also gives for a nice arrangement. Now, as far as which is more accurate, the digital level or the protractor with the bubble, they're both the same. Okay, the protractor with the bubble, even though it's a mechanical instrument, is down to like 0.2 degrees. You can easily see with the bubble. You need the proper, like this propeller comes with the Allen bolts, 6mm, so you're going to need something to tighten that up with. Something that also will fit up against your torque wrench, because you're going to need a torque wrench, and the manufacturer of the propeller will tell you what the torque specifications would be for the inboard and the outboard hardware. Of course, the main bolts take more torque than the little bolts. This is something for the smaller bolts outboard. Now, the Whirlwind has a 12-point bolt, which means any kind of a regular wrench with a 12-point closed-in box end would fit on that. This is a 1/4 inch, and then the back side is a 5/16. Now, we also have a just little nut driver, and it makes it easy to just quickly assemble it and then go with a torque wrench afterwards. Grabbing the propeller, having already inserted the bolts, we're going to install it. Now there's a spinner bulkhead here. Make sure your orientation of the blades, if there is one, to the spinner bulkhead. Usually there'll be like a little cutout for the blades to clear or something. Like this has holes in order to be able to get to these outer bolts. So if there is such a feature on your spinner bulkhead, pay attention to that, and then insert or install the propeller accordingly so it then lines up with it. Initially, just kind of get everything started with your fingers. The other thing you want to pay attention to as well is, make sure that your threads and your lugs are clean and free of debris. And it doesn't even hurt to put a tiny little bit of WD-40 or a little bit of oil on the threads, because you're not relying on the threads for keeping the bolts from backing out. In fact, you want the threads to be at least clean and free of dirt. But a tiny bit of lubrication doesn't hurt either. Steel against steel is not always the best thing. Now we're just going to snug it down a tiny bit, mostly just to get the propeller flush up against the engine. Our guard dog is busy working. Now at this point, what I do is I take a wrench and what you want to achieve basically is the propeller being stationary up against the engine, but not tight, because if it's tight, how are you going to turn the blades? So, and you do want to turn the blades because that's what we're trying to do. We're trying to set the pitch of the blades to the number of degrees for our first flight or our first run-up. So now I'm going to back off each of these, and I'm going to then tighten it just until I feel a little bit of resistance, and then the tiniest bit more. And the reason for that is I want to be sure, and you're just going to do that to every bolt like that. I want to be sure that the propeller is in fact stationary up against the engine and doesn't wobble, because if it wobbles, how am I supposed to be able to rely on any surface to be true? Like for instance, if I now take my smart level and I set it up against some vertical surface here, I want to make sure that that surface stays true for every measurement. So if I were to now put this up against here and it's flat, and I would then set it to 0, then I could now keep this setting and I could use it, I could move it out to the tip, and I could use it as a reliable reference to this surface. Now let's talk about that for a second. Let me also grab the protractor, and I've got the protractor here. It's the same deal. You put this up against some flat surface and you center it. Now this has a little locking device on the back side, a little red knob, so make sure that's loose. And then I set this until the bubble is level. Now we're going to talk about reference angles, as in reducing the complexity of the of the brain thinking or math associated with what you're really trying to do. All you're trying to do at the end is have the same reference or the same amount of degrees from this surface to the whatever tip of the prop or where you put your wooden paddle from Whirlwind. You're not concerned about this being 0 right now, okay? You don't have to go back and level the plane. You don't have to put shims underneath the tail. You don't have to do any of that. What you do want to make sure of is that the plane is not allowed to move up and down, okay? Because this angle is going to keep changing when that happens. You don't want to do this out in the wind. You don't want to do this with no support underneath the tail, like the plane just sitting on the suspension. And if you did, let's just say you did 2 blades, and your suspension was kind of like up a little bit, and then someone leaned on the plane and it fell down, and now it took another different set. Then the 3rd blade is going to be all messed up, and so that's no good. So you want to block the plane from moving on the suspension. Don't do this in the wind. Don't be concerned about this being 0 degrees, because let's say this was 5 degrees and you want to set this at 20, and then you really just set this to 25 because you're already at 5. It doesn't make any difference. It's the difference between this and this that is your total angle. It doesn't have to be 0 and 20. It could be 2 and 22, or 1 and 21. So just keep that in mind. It makes it easier to do the job. Okay, now rotate your propeller until one blade is level or roughly level with the ground or your hangar floor, and then at that point get a quick measurement so that you can get the other 2 blades, if it's a 3-bladed propeller, into the same place. Now after that, after you've measured that, then you move along and you bring your tools in, and we're going to work on the protractor next. The protractor you would put at the tip of the blade and tighten down your little screws here. Now I have to say, if your propeller is anything like this one, where it is not flat on the back side, I would say that the protractor is fairly or unreliable to be used in this fashion. You can still use the protractor on a propeller with a slightly rounded back, but you would install a tool like this that will give you a flat surface from which to work off of. If you install this just very lightly, make sure it's somewhat vertical until you start feeling a little friction. Just tap it just another 1/16 of an inch, and then that locks in place. Basically, you want to initially just kind of look for the general status of things, meaning you're looking at your whole propeller. You know which way your engine rotates, or if you don't know, you need to find out to make sure you have the correct propeller. These blades have the nickel edges, or the leading edge here, which obviously the engine is then going to rotate in this direction. It's going to rotate clockwise. If your propeller leading edge was down here, it would be the wrong propeller for the airplane, and you'd have to exchange it, unless of course your engine turned the opposite direction. This is a Viking engine. It has a 3-gear gearbox, meaning that it does turn in this direction. If it had a 2-gear gearbox, it would turn in the opposite direction. Some engines turn clockwise, it's called. Some engines turn counterclockwise. Once this is installed and you've verified that, take a look at the basics, which means go back to your initial flight training and look at what makes an airplane fly. The propeller is nothing more than a wing. If you have a negative angle of attack, you're not producing any lift. You cannot fly with negative angle of attack. If you have 0 angle of attack, you're not producing any lift. So you know, just from the basics, that the propeller has to be on this side of vertical. Okay? Now, that kind of gives you a mental picture, because I've seen time after time Someone will set two blades, and then this one will be set at perfectly 20 degrees, but it's in the wrong direction. And guess what? It's just not going to run, or it runs with vibration. Now, if you kind of go vertical just to get started, and you already set your protractor here to the bubble being level, then you can take, also pay attention that you don't like flip your tools around, you know, or this way or that way, you know. What I do is usually get your reference. Okay, I know my tool, my scale, my level, or my protractor is now going to sit this way for the rest of the time that I'm doing this job. So I put it somewhere where it'll be right there. And every time I grab it, bring it here, I'm organized, and it's going to be the same. And I make sure that I don't touch the internals so that it doesn't change. If you think you touched the internals, maybe you can double check to make sure it's still level. Now, then I'm going to put it here, and I'm holding it parallel with the piece of wood. Okay? Now, then you want to rotate the blade to the bubble becoming level again. Now, that's only true. We did show you how you go in here and you set the bubble to level. Next thing you want to do is look at the actual protractor. Okay, what does that mean? Well, for me, that means how. And don't be confused about the numbers, because remember what I said, it's all in reference to whatever you're at. So right now it shows that I am 1 degree past 90 here. Okay, so let's say I want to do 20 degrees. I'm going to undo the lock. If I go to 90, I've already gone 1 degree. If I go another 20 degrees, there's 10, there's 20. That's 20 degrees I moved. I'm going to go back 1 because I started 1 on this side. That means I moved it a total of 20 degrees, or I shifted it over 20 degrees. I'm going to lock it right there. Now, if I know that I'm going to tip the front of the propeller in this direction, which means that if I just want to test it now, if I tip there, eventually it's going to go level. That means that, yes, I did it right. I went the right direction. Okay? So now my tool is set up to be used. I'm going to tip it until the bubble gets in the middle. When the bubble is in the middle, I'm at 20 degrees. So that's my job now. I'm going to turn the propeller until the bubble is in the middle. Now, it can be that you have to, you know, make sure, like I said, that the inner bolts are just tight enough that the prop doesn't wobble. The outer bolts have to be totally loose, or nothing's going to happen. You're not going to be able to do this. A little bit of wiggling and shaking back and forth will help you if it's tight. Once that's done, you can now take your wrenches and just snug up this one and the one below just a tiny bit, and then move on to the next blade. It's not necessary if there's already a little bit of friction here and you don't feel like the blade's going to move, because you can always go back and double check when you're done. At that point, don't touch this blade. You know, grab the propeller by another blade. And some people take the spark plugs out so that it's easy to rotate and all that. You can also just turn the engine very gradually so that the compression is not keeping you from turning it smoothly and shifting the plane all around. Now once you get back here, grab your tape measure again and you measure that 40 or 41 inches that we had, and okay, and that just has to be, you know, plus minus a quarter inch. And then you do the same thing again. Put your tool on here, or the protractor at the tip if it's a flat bladed prop like a warp drive. Look at the thing. Okay, it's a negative degree. That's definitely not what I want. Okay, that's vertical. I'm going to be positive angle of attack from there. 20 degrees is going to be somewhere over here. Take your tool, don't disturb it, put it on there, and then, you know, make sure you hold it so that it stays parallel with your tool. Rotate it until bubble is in the middle. And this has to be, you know, very, very, very precise. You want the bubble to be exactly in the middle. And I would probably go through this, you know, twice. Even after you tighten down the bolts a little bit, go and check it again. Make sure that it's right on the money. If it's out quarter degree, half a degree, then you will have vibration. Now, that being said, don't get completely you know, bogged up in the details as far as the precision of this for your first run-up, because chances are with a Viking or a Rotax, or, you know, let's just say those as far as the RPM, you're going to want 4,800, 4,900, 5,000 static RPM with the brakes locked. If you're not even close to that, and you spend 3 hours setting the propeller at the absolute precision pitch that you can get, you just wasted 3 hours. So you just kind of get it close, run it up, tie the tail down, make sure you're close to your takeoff RPM, and then at that point you set it perfect. Now, one thing you want to keep in mind when you're working on these propellers is that you have a set of big bolts and usually a set of smaller bolts. Well, guess what? You want to prioritize the bigger ones, because the larger bolts, because if you look at them as equals, even though you're torquing them to different values like the manual, what you're going to end up with is some problems. If you focus on these as being your main bolts and these being your secondaries, you won't have any issues. Let's just say that you're all set, you got your pitch set up, they're nailed, you got it right on 18 degrees or 20 or whatever you set. By the way, the warp drive set at the tip, usually you want to be from 10 to 14 degrees. You know, somewhere in there for most light sport engines. Probably getting like 11 degrees at the tip is a good starting point for most light sports. On the Whirlwind propeller with the wooden paddle, somewhere around about 17 degrees will give you a good start. Now back to the bolts. If you were to tighten these first and didn't snap them off, which of course you wouldn't because you'd be using a torque wrench, and then you went back and you tightened this down, these would be loose again, okay? What you've got is a clamshell design. You've got a front piece and a back piece, and they're designed to be pulled together to lock the blades in place. You want to tighten them and pull them together using the larger bolts, and these are just supplementary bolts to stabilize the blade, and you torque those last. Same when you loosen things up, you want to loosen these up first, because if you loosen this up first, you're increasing the torque on these bolts by the spring force in the two hubs. So tighten these first, loosen these first. These are last. Alternative to using the protractor is to use a smart level. Of course, they have their own little tricks. You have to learn how to use yours. Basically, you're going to set it up against the prop hub after the propeller is just tight enough that it won't wobble, and zero it. Use the button to zero the level, then move it out to keep it exactly the same way as you had it in there. Lay it up against the alignment tool and see what it's reading, and then just rotate it until you get the number of degrees that you want. Then what I usually do is I take my level, I kind of just set it somewhere so that it sits in the direction that I want it, so that when I get the next blade in, pick it up, and it's ready to go. Then I don't have to worry about if I had it this way or if I had it this way or whatever. You know, it just makes it a little easier. Okay, we've already put the backing plate on here on our prop spacer, and then the propeller. We torqued these on the warp drive to 200 inch-pounds. The new bulkheads have clearance holes so you can set the prop. We got our face plate on here. Next thing, the spinner goes on. You've got your prop cutouts and your index marks that keep it from rotating. It goes on like this. Feel it all the way around, make sure it's in. Put plenty of blue Loctite on your bolt. Add your front cap, and then sight in for trying to hit the front part of the spinner there with your bolt and get that started. Can be a little bit of a challenge, but also can be done. Let's see here. Doesn't feel quite right yet. Once you get that started, then it's pretty easy from there. We got it finger started. And grab your wrench. Now, before you tighten this, just snug it up just like that, so everything is still kind of loose, maybe even more, a little looser. Then just make sure everything is where it should be. The index marks are in, the dome is all set, and then do a quarter turn or so. Feel it again. I can feel it that's starting to get a little tight right now. We'll do another quarter turn. Okay, now it's kind of, can barely move it with my fingers. Then I do another quarter turn. Now it's very tight, but I can still move it. And then I'm going to do another quarter turn and I'm going to stop. And that's where I'm going to leave it until I fly it. And then on pre-flight, you just do the same check, make sure it's tight, and that's as tight as you want it, not any tighter than that. Before you start your cowling installation, make sure to get a prop extension from Viking. Most cowlings use a prop extension. This one already has one mounted, and the reason for that is if the airplane is on a gyrocopter or something, it doesn't really matter because there's no cowling. But if you want a cowling that fits around the engine itself, having a little bit of an extension makes it easier to fit the cowling and get a streamlined look of the airplane. The extension basically comes with lugs machined as part of it, and it goes on to the lugs that are on the propeller hub itself, and then the propeller goes on top of that. In some cases, a spinner bulkhead goes on first, and then the propeller, and then the bolts go through everything and are threaded into the lugs behind. And the way that the Viking supplies the propeller through Whirlwind is that there are now Norlock washers on the front of the propeller that lock it all into place, so no safety wires required. Okay, we're going to fit a cowling to a Zenith. This will be a generic video. You can use this procedure for any of the Viking cowlings. It's a very straightforward procedure. You're going to be getting a top and a bottom cowling. They come raw out of the mold like this. We leave as much fiberglass on around the edges as possible in order for you to have the maximum amount of available trimming surface. Be careful, of course, with the sharp edges. There's a gel coat finish. It's not meant to be a perfect finish, so it's going to be a smooth finish that needs to be sanded for paint. The first thing we're going to do is mark a couple of things. We're going to grab a Sharpie and find a center of the front opening, well, what will turn into an opening of the cowling. There's about 12 inches, so at 6 inches we got a center, and of course this is a little bit off here, but if you measure from where the radius starts, in fact it's 6 1/4, 12 1/4, so that'll be 6 1/8. So right here, that's going to be the middle that we're going to be basing most of our measurements from. Now, I picked out a ring here. It happens to be 11 inches in the outside diameter, so I'm going to lay this on here, and we got 11 there, so 5 1/2. Put that on my mark, which is 5 1/2. It's right there. Now I know that there's an inch extra material here on the cowling that's provided in the mold, So I'm going to go 6.5 down because of that. So I'm going to go another 1/2 inch, and that'll give me the 5.5 plus that little bit that I know is already provided as a 1-inch excess as the cowling comes out of the mold. And I'm back on my 5.5 there. Now this is not real critical because this is really just for clearance. This gets trimmed out to clear the propeller hub. And in fact, you don't necessarily have to trim it this much. We are trimming it this much because we have some bolts on the back of the spinner bulkhead right here that need to clear, and they spin around here. They're used for balancing the propeller. Now, before we start cutting that, let's mark other things that we want to cut. For instance, we have the exhaust system on the engine on the pilot side. What I would do is take a couple of straight edges in order to try to get a feel for where the exhaust system is located, and come off of the back of the spinner bulkhead. That's where most of your references are going to be. And from that you can get a good measurement to where the exhaust system center would be, which here would be 23¼ inches. Okay, and then we're going to do from the center line of the airplane, and we get to the center 10.5. So 23¼ and 10.5 from the spinner surface is what you're going to measure. So then you can do a similar thing with the cowling. You could, for instance, set it up like this, and you could put it up against the wall so that you would have a true reference here, and then you could measure your dimension here, and then you could do the same from the center line from the inside. And then once that's been marked, we already kind of cheated a little bit here and put those markings in. You can drill that with a hole saw. You can cut this with a jigsaw, and then you can cut around the nose wheel here, which you also just transfer directly from the airplane to the cowling. Now with the jigsaw, what you do is you go and buy a diamond or a carbide dust coated blade, not one with teeth. After that, we're going to cut the front. Now, since we do know that the extra material in the cowling as it comes out of the mold is 1 inch, we're going to take off almost 1 inch. In fact, I'm going to mark it 1 inch, but then we're going to keep trimming short of that in order to make sure that there is enough material left. Now, on the bottom cowling, just to kind of make it efficient, quick and efficient, I would just cut it at 1 inch and then sand it, and then that's done. And then I would spend time on the top cowling fitting it to the bottom, rather than trying to fit them both up, because, you know, if you're a little bit short on the bottom, it can make it up with the top, and so forth and so on. So, but, you know, try to get it parallel, because you are going to put in a hinge here eventually, which will serve as your fastening mechanism, and then do that to the other side as well. Okay, just grab some 2x4 or something straight, glue some coarse 40 grit paper to it, and just quickly sand this even. Now be careful around the edges. It's very easy to think that you're flat, but that you're not. You know, like if the cowling is warped or something, then you're not actually sanding flat. So just kind of hold it so that the natural curvature is in the cowling. If you cut it somewhat straight, you shouldn't require too much anyhow. Now, the next thing is going to be to trial fit this thing, and in order to do that, we have to clamp it up front here around the back of the spinner. Actually, we're doing just fine. Looks like it's going to fit just fine. So now what I'm going to do is I'm going to go and get a chair or something I can put underneath here, or my forklift, and that'll kind of hold it while I keep working. Now what we've done already, if you want to get a piece of extruded piano hinge, the MS20001-4s from Spruce, and cut yourself a piece along this edge of the airplane, rivet, pre-bend it so that it has the right shape, and then rivet with 1/8" or 5/16" pop rivets. This airplane's had a lot of different cowlings. That's why you see, you know, kind of a mess here. But that's because this is a workhorse airplane that's been used for a whole variety of different engines up through the times. Now, we're putting on the mating half of this hinge, and that's going to be the part that holds the cowling to the airplane. This is actually one of the more important parts, because this part here, if you put enough rivets here, will not wobble up and down at all. So if the fiberglass is really securely fastened to this, that is all the support the entire cowling needs, and no fasteners are needed up around the top here. I like little vice grips like these. They're quick to release, they work good, and we're not at all trying to get the cowling in the right place the first time we put a clamp on. What we're trying to do is go back and forth, and eventually get it in the right place. But we have to start somewhere. Right now we got a chair on the bottom, and we have a clamp over there, and you can already kind of tell that this needs to come this way. But that being said, for now we're just kind of putting the clamp on there, and then we're going to go and look at the front and see what the front looks like. And it looks like it's low, so we're going to kick that up. We're going to see where it might be interfering, where it might be hitting the airplane, and then adjust maybe with the chair or with blocks or whatever you have around that's handy. You could also clamp here, which is going to be our next step, but we do have to put a 1/4" spacer in here when we clamp it, because we don't want the cowling to rub on the spinner. Now what you can do there is just simply cut yourself some paint sticks, maybe 2, maybe 3. I'm probably going to go with 3, because everybody wants a really tight fit until you start removing and putting the cowling on and off. That's when you kind of regret going so tight, and you wish that you had given yourself just a little bit extra space in order to make it easy to get the cowling on and off. And then just any kind of a C-clamp will work to hold that in place to the spinner bulkhead. And we're going to do that on both sides, and then we're just going to move the cowling sideways until it looks centered, and we can see that on the inside of the spinner bulkhead. Now at this point, what you want to do is, in addition to just kind of watching the distance here and the distance here and the gap all the way around, is also step back and look at the airplane, because your eyes don't lie. And then look at this edge and compare it to the wings or to the rest of the plane. And then keep adjusting it up and down until it just looks right. And once you get this, then you want to go back to the other clamps and also on those, make sure it looks right, in addition to making a few measurements. Like you could even count rivets if your airplane is put together with rivets. If the spacing, if it was a pre-punched riveted airplane, then the spacing between these rivets are going to be identical. So you could count rivets. You could even you could measure from here, and simply get the cowling so it looks straight on the airplane at this point. Okay, now to make a cowling go around a nice shape like this, fiberglass is usually curved. What we have here is a sharp corner coming from the airframe, and trying to get the cowling to go around that corner is difficult. So we took a uni-bit and we just drilled a hole a little bit further back here, and you make a nice rounded cutout here, and that way the fiberglass can go around the corner rather than having to go down and straight over. Now what we're doing at this point is we are going to drill some holes here and there and put clecos in. That doesn't mean that they're going to be the final holes. Okay, don't be worried about putting cleco in here and there, and try it, because it's fiberglass, which means when you're all said and done, little holes in fiberglass, you can just countersink them and fill them up with a little bit of Tiger here that you can get at any of the auto parts stores, and then sand it smooth, and then go do your paint. But rather than trying to hold everything with tape and clamps, at some point it's easier just to put a cleco here and there and then readjust and keep moving it around until you get it exactly where you want it. Okay, so we've preliminary fitted the bottom cowling. This took some time. This is a cowling that came out of the initial mold cruiser and the 750 and the 650 using the Viking engine. So we had to make a few little cuts, and we're going to update the cowling so that that's not necessary. For those that have received cowlings already, it's not a big deal. Fiberglass is really easy to do, and there's nothing major. Let's point out the areas of interference first. One is in the front, where the gearbox is located. In fact, we will probably leave this as a drain area for the gearbox, since that's what it is. We'll pretty this up and we'll use it as a drain. It could also be fiberglassed over. The other one is right here in this corner. The aluminum piece here will actually be smaller on production gearboxes, so there won't be quite this much interference. And like I said, we'll change our mold so this gets covered. But for the few cowlings that have already shipped, just cut a hole, sand this area, put some paper or tape around it and build it up a little bit, and put a layer of fiberglass before you paint the cowling. Now the thing that you want to do is try to maintain this gap around here, and you will find that every time you move the cowling a little bit, it changes. It will change. But your ultimate goal is to have the cowling hang by itself, not touch any part of the engine, and kind of be, not loose, of course, because it's already attached to the firewall, but every time you bump it, it goes back to the gap that you want. What we did as far as attaching it to the airplane is adding those hinges we showed earlier, and we held the cowling up to it, and we drilled a hole and we put a cleco in. We went and did that on the other side. We went back to the front, verified our gap. If it wasn't correct, we would shift it a little bit one way or another until that was done. By doing that back and forth, eventually we got to the point where the cowling is not touching any part of the engine and it has the correct gap up front. The other thing we were looking for while we were doing that was holding the bottom up, and we were using a couple of jack stands to do that. We have left a little additional drop down here so that the radiator can be adjusted all the way down to here for those people that live in a very hot climate in order to get more air on top of the radiator through the scoop inside. For those that don't need that much cooling, and after you're flying and the radiator has been set at whatever distance necessary for the proper cooling, you could then, if you don't paint your airplane ahead of time, make a cut here and then just lift this up and re-glue it to have the cowling only go down to the level necessary for the proper cooling. And we will also in our mold round off this little corner a little bit for future cowlings for a nice look. As you can see, we were not concerned. Now these holes are the correct holes, but there's a few little holes that were not used, and we're not concerned about that. That's something that we had to go through to make that cowling fit exactly where we wanted it. We're just going to countersink the holes that we don't use and put a little Bondo in them. Now the other side, we've already put the rivets in, and you can see that most of the holes were actually used for the final, but we do have a couple that we were using as initial alignment, and we're not worried about that. We're now going to take a Sharpie on the inside and mark this edge all the way down, or where we can get to it, and then we're going to remove the cowling and transfer the bark to the outside and make a nice cut so that the cowling fits the airplane. Okay, we're reevaluating the straightness of the cowling on the sides. What we've done is just clamp a straight edge of some sort that's flexible enough that it can bend around the corner. Flexible enough that it doesn't distort the cowling when we push on it. We have it parallel here, and we're carefully pushing it up against the cowling and holding it as we go. And we can see now that the shape of the cowling has changed a little bit in the front, and that we need to redraw a line in order to keep this level before we add any hinges to it. So we do that, and we'll cut that. And we notice that from looking directly from the front of the cowling and just looking with our eyes, and we could see this corner had turned up. And it's not the fact on the other side, so we're just going to trim this one side. Okay, now grab some MS 20001-4 hinge from spruce. This is a 6-foot length. Then you need another 3-foot length for the ends, and that's all you're going to need. So 2 pieces. It's 1.5 inches wide and it's extruded. Cut it. I ended up having a little piece left over on a 6-foot to do the 2 sides of the cowling. Let's kind of hold this over there and just show where it goes. You don't necessarily have to go all the way around the corner in the front because it just makes it hard to get the pin in. But you could go a couple of inches from the end, and then it's bending. Now you need some room over here, another 2 inches, in order to get the pin in as you're separating the cowling. So from here to here. Eventually we're going to make a little opening here to get the hinge pin in and out. The next thing we're going to do before we install them is on 1/2 of each hinge. When I go over to the bandsaw And we're going to take 1/16 of an inch off each one of these loops here. So this one, this one, this one, and we'll show the reason for that after we do it. Let's go to the bandsaw. One reason that we left a little bit of hinge off too on the 6-foot piece is the hinge pin that goes in needs to have a bend at the end in order to create a handle. So we're going to put a point at one end and a bend at the other end. About a 1-inch handle will be working fine for us. Those are the pins. Handle at one end and a point at the other end. Okay, so what we've got now is a set of hinges with a pin and a handle. The reason that we took out a little bit of material is that we're not going to use this as a hinge. We're going to use it as a cowling attach feature. Now, to try to get these to mesh like this when we put the cowling on with no relief, it's difficult. Now there is some play in there, which makes it easier to drop the cowling in place. Okay, now grab one hinge, half. The handle goes towards the door of the airplane, and the point, of course, towards the propeller. Now it's going to sit this way with the flat side on the inside of the cowling. What I'd like to do is to pre-bend the assembly. Just kind of grab it like this and watch the cowling. We know it's pretty straight over here, but from here it starts bending and more at the end. So I'm just going to kind of bend the whole thing at one time and bend it more in the front than back here. I'm going to have to go a little bit further than the cowling, otherwise, because there's spring back. And I'm bending the pin and everything at the same time. And then just keep trying it until you get it perfectly bent without any stress on the hinge, because you don't want it to deform the cowling. Now we're going to install this. What we have to keep in mind is that the cowling comes in here a little bit curved. Now on the Viking we do have a little straight edge here and a little bit of straight here because the propeller is lower than some engines because we have inline engine. So we don't have to be so concerned, but on other cowlings, the cowling will start curving immediately, in which case it might be preferable to take some of this hinge off. But in this installation, we're going to leave it on, and we're going to let the bottom hinge stick up. We're not going to go right on the split. The reason we don't go right on the split is you will then be able to see these little gaps from the side, and it doesn't look as aesthetically pleasing. But if you raise it up an equal amount everywhere, like 1/8 of an inch, yes, you have less to drill in, but there's still plenty if you're careful. And you put the hinge in like that, and then you worry about the top later. So we're gonna leave it together, and we're gonna clamp it and cleco it in place right now, and then we're going to rivet it, and then we're gonna do the top later. Grab something round and cut some of this inside out, and trim off more as you go later, just to get it started to clear the propeller. Doesn't look like much yet, but we did stick the cowling, the top cowling on here. what we did is we just kind of took away a little bit of the flashing around the side so that it would tuck inside. This, by the way, is slightly different than our standard cruiser. Our windshield comes forward much more. We changed the airplane a little bit. Yours is going to be going straight across here, but that's no big deal. You're just not going to be cutting it like we did. It's just going to go right across. Now what you want to do is tuck it on the inside. Now before you even get started, right in this area here, there's a fuel pump on the engine. That's the high pressure fuel pump that runs the gasoline direct injection. This is going to be the tallest point on the engine. In fact, it's tall enough that we have rounded off some items here to try to clear the cowling. What you want to do is get a 1/4 inch or a 3/8 pad, maybe a mouse pad or something like that, and lay it here, and then lay the cowling on top of that, and that's going to give you the clearance. That'll tell you where the cowling needs to be in order to clear the engine. What, on the inside? Yep, inside. Yeah. We're going to have to cut it again, but that'd be a first cut. Now make some scrap pieces with some 1/8 inch holes for your clicos and line the top cowling on. Keep it as high as possible. Don't try to trim it down, because keep in mind you have to clear this pump back here. And then pull the cowling forward now after it's been cut and set it up on top very carefully. Maintain your gap and then just start carefully drilling holes. Everything is kind of flimsy right now, but in fact I'm going to take this and turn it the other way so that it goes up a little bit, so I can reach the top cowling with another set of holes. And this is where you might have to reposition a couple of times, but we're going to try not to. Try not to drill into the engine. There's nothing behind here, so we're okay, but just always keep that in mind, that there's an engine inside the cowling. Okay, I'm going to add a piece of tape from the window ledge, which on some airplanes you have to get around that. So we're just going to take a known entity as a 1.5 inch or a 2 inch wide tape. And we're just going to run that down along here. So that, the reason for that is when we put the cowling on, we could take another piece of tape of the same exact width, and we can put it on top of the cowling, matching it up with the back line, and that'll tell us where to cut the cowling. So that's just some little trick that I learned from somebody. Okay, so now I'm going to tape this, and as I go along, the reason I'm kind of taping it before I mark the back is everything is kind of flexible right now, and I want the cowlings to be somewhat even with each other, so that not just the gap up and down, but also that they align as I move back along. So I'm just kind of pushing the tape in as I go, and get the cowling kind of close. I know that once the cowling comes down in the back here, I trim from the back. It's going to come further down, but I have to start somewhere. And I know that the front is where it needs to be because I do want my height in the front to clear the pump. So this is never going to change. It's going to sit there. But eventually there will be another line here. This will be moved up a little bit, and there'll be a diagonal cut here. We're moving more in the back than the front in order to get this back down. We're going to tape both sides. Then we're going to transfer our tape from here over to here next. Okay, so we're putting this back in, lining it up on the back here to show us on the cowling where we need to trim it. Of course, you can use little sections of tape too because it's not always flexible, but this seems to work for me right now. Now, while you're doing all this, you just want to keep moving back and forth, double checking everything. Like for instance, if you did this, but you didn't check the front, then this will be wrong. So you want to keep your gap in the front where you want it while you work on the back. Keep this even. Try to keep as little strain in the cowling as possible, which means if you have to push something really hard to tape it, then something's not quite right. So you need to readjust, maybe loosen up some clecos. Once you do one side, do the other side to get the cowling where you want. That probably means you might have to loosen the other side again after you get this done and kind of work it until it goes in place without having to force it. Because if you force it during construction, you're always going to have to force it later when you want to put the hinge pins in to take the cowling off. Yeah, just carefully cut the tape, not cutting into the airplane. And leave the tape on the cowling that's going to get cut off. We're going to put some hinges on to just make some lines in order to get it back in the same spot next time. Alright, so we're just drawing all the way around the spinner at this point. That way we can do like a 1/2 inch offset on the inside and get a nice cut on the cowling so it's even all the way around. Okay, so we've trimmed the back so it's all the way down onto the airplane, and we're kind of pulling this back a little bit, tucking it inside again, and we're drawing a new line, and it ends up being a wedge, like I said, where we're taking off here, and it goes to nothing up front to maintain the height over the fuel pump. Okay, we're going to mark this. It might have to be trimmed a little bit later again, but the reason I'm coming a little bit at a diagonal here is there's plenty of cowling, but the cowling flares out here, and I don't want that. I want to cut that away. There's actually a gap here, but as I get further forward, it's laying up against the airplane. So I'm going to go forward a little bit until I get there. Now, keep in mind the cutout we did on the corner of the cowling. We don't want that exposed, so you can see that back here. I'm going to make a curve here, and we're going to go with that, and we'll see what that looks like. If we keep going straight, we're going to end up with a hole here in the curve that we cut out. So we're going to do this for now, and then we'll work on trimming this later. Just fit it in where the bend lines up, and then we're going to have it 1/8 of an inch up from the bottom of the groove there, and then we're going to drill on the loops to get more material. We'll put just one in the middle, and then we can pivot it about that and get the front and the back equal. It should be marked by now, so we can drill it on a block of wood or right here. Okay. Okay. Now, we don't want to put any twist in it, so what I would do is I would not line this up parallel and then drill and go with that. I would look at the whole thing and then even out the ups and downs. And as you can see, it's already going higher here than there. So I'm going to get some spring clamps, and I'm just going to, without forcing anything, just clamp it so it'll allow it to go where it wants to go. So then drill just every other loop is plenty of rivets. I wouldn't bother countersinking or anything. Some people get a little carried away with what they think they need to do, but all it does is weaken the fiberglass, and none of this is countersunk, so I would say 1/8 inch. I even use over here 5/32 rivets. This is the most critical part to keep the cowling horizontal. But here you can go ahead with the 1/8 inch AVAX rivets. Front here I'm going to do just for the first 4, so I'm going to do every hinge loop just because it's a little more load with the air load up front than it is on the sides. Not that it would ever come apart anyhow. Also watch out here, as you can see the hinge kind of rides up a little bit here because of when we started evening out the front and the back without putting strain on the hinge. So when you do get a little more gap here, be careful that you look behind here that you actually are drilling into the hinge, keeping it all into the hinge material with the rivets. Want to stay.
How come they?
Let's see. Okay, so we're going to line up those marks there. I'll do one of these that lines up.
Yeah.
Okay.
Can you see it?
Yeah, I see it directly from here. It'd be easier.
Okay. All right. Okay. Get it up there and then I'll hold it.
I got it.
Okay. Now this is way out.
Yep.
Okay.
Middle point underneath here. Yeah, we can go up a little bit. All right.
Okay, now it's coming down.
So it doesn't pop out right there.
Yeah.
be anywhere near it. Okay, Vern. Okay, when this is all done, there's no reason to have, like we showed, pins in the beginning, full size. The pin is meant for a hinge, to make the hinge very precise, but it's a bear to use when you're trying to install and remove a cowling. And this is like 79,000, so you can just measure it and then order from McMaster-Carr or any company that carries piano wire, and get something that's about 15 thousandths less, and substitute your hinge pin with a smaller wire, and then it's easy to remove and install the cowling. If you try to use the original rod, you're not going to be happy with the installation. Alright, so we have to get the wire in here somewhere, somehow. So what I usually do is you look at the part of the loop. If this has the loop that's the furthest back, then you use this as a measurement. If the top hinge has the loop further aft, then you use that as a measurement. So this, I want to be able to see the beginning of this loop after I cut my hole, so I know where to start the pin. So I have to cut at least to that point. And then the height has to be from here to the center of the pin. So it's about like right there, a little bit extra. And you probably don't have to cut all the way straight here. You can come up, make a little teardrop thing, and then you can get your pin in. We're going to use the undersized pin. Now, in order to get the cowling actually to stretch down to the area where you need it to be to install the pin, it will be a lot easier once you have some kind of a handle to grab onto. That's going to be, once we get our air intake up here, we can use that as a handle. We can pull the cowling down with that. It's still not very hard right now because we don't have any anti-chafing protection underneath here. But once we put a weather strip piece underneath here, so it doesn't, because the fiberglass is very abrasive and it will wear into the aluminum. But once we have weather strip underneath here, then it's going to take a little more force to compress that to get the pin in, which once we install this for the air cleaner, to get air to the air cleaner, then we can pull on that. And this is also where our oil dipstick is going to come out. So once this is flush here, we can actually check the oil without taking the cowling off. Now we'll explain how to put this in. Okay, so to install the NACA inlet for the air cleaner, you would first put it upside down, and you can get a very rough you can draw the outline here, and you can transfer that in a little bit and make it too small in the beginning. And then you can, another way you can do it is you can take a piece of cardboard, you can trim it to here, and you can lay that on here and trace it. Many ways you can transfer the pattern of this to this. Then you want to look at your installation of the engine in the airplane and see where your air cleaner is located. It's going to be somewhere in back here in this area. So what you need to do is judge the distance away from where the cowling stops. Not necessarily exactly like this, because this airplane has been modified. Let's say you're building a Zenith cruiser or a 750. In fact, the firewall would be way back here. So this would be an illusion. The distance, you have to judge where you want to place this. Also try to get it on a flat area of the cowling. You don't want it so far forward that it starts curving, because the part that you're installing is flat. One trick, if it is not very flat where you're installing it, or if you want it to fit up closer, is the more surface area you have here, the harder it is to fit on a curved surface. Like for instance, if this was trimmed back just enough here to be able to get some rivets in, then if the cowling curved off here, then it would help, because this sticks out and would hit that curve. You can install it very simply by drilling and pop riveting the thing in place. You can also, if you want to be fancy, only use 4 pop rivets and some high-sol adhesive or any kind of a glue to glue it in place, epoxy of some sort. But just simply pop riveting it in place is quite acceptable and will look just fine.
One method for positioning the air scoop precisely is to remove the top cowl, place the scoop on the engine with some rags underneath to support it at the correct height. Use the dipstick through the hole in the scoop to precisely position the scoop. Add your adhesive to the scoop and replace the top cowl in position with the bottom cowl. You can add more rags as needed to force the scoop in contact with the top cowl. You can get your arms through the area behind the spinner at the front of the cowl.
Okay, alright, so other than a few more trimming here and underneath, the cowling is now fitted and can be made ready for paint. The easiest is, because this is a gel coat surface, is just take some 240 paper. If you want, you can put water on it and wet sand the whole thing out, but also just dry sanding with 240, keep changing your paper is fine. And at that point, you can either just paint it, because you do have a surface already with a gel coat, or if you want to prime it, you go ahead and prime it and then paint it. Or you could bring it to someone, like a body shop, and get a deal from somebody that can finish it for you. Now, to prep the cowling, any blemishes that you might have, a couple extra holes for the that you used during the assembly and alignment, you would simply take a countersink and countersink the hole. Not make the hole any bigger, but at least remove some material that when you put just body filler in there, it has something to bite onto. So you just put a piece of tape on the back, fill it with body filler after countersinking, and then just scuff it with some 180 paper and then 240. Any areas if you want to modify something, or you have something hitting the cowling and you have to cut a little hole, you basically go to Home Depot or Walmart, buy a package of fiberglass cloth and fiberglass resin, which comes with hardener. A lot of times you just tape the inside, cut a little piece of glass, mix a little resin, put it on there and use a little brush. Make sure that the areas that you're adding the glass to, about a ½ inch around the hole that you cut out, you grind away the gel coat and let the fiberglass have something to bind onto with the tape on the backside. Many different ways to do it. A little bit of poster board on the backside with some packing tape on it so that it'll release afterwards. But little localized repairs like that, take a look at YouTube how to do basic fiberglass repairs, and then you can buy the material and do it very easily yourself. Not at all hard. Alright, now after you have done a couple of flights with a radiator at the specified location that we're going to tell you in the next installation in DVD, you want to make a simple cut around this corner, and then bring this up and use a couple of pop rivets to get the shape of the cowling where it blends in with the radiator, and that takes care of the adjustment. That also allows you in the future to bring it down. If you need more cooling, you're basically going to adjust this cowl flap where you want it, depending on the cooling situation that you have where you live. And that regulates the amount of air. Basically, lowering this also means that the standoffs that lowers the radiator have to be made longer, and the hoses for the radiator will then come down with it. But right now, in Florida, we have found that having it right here, which is a couple of inches down, is adequate amount of cooling for our situation. Now, of course, if you live in a maybe hotter climate, and you have a stall airplane that's not as fast as this one, maybe you do want to lower the radiator another ½ inch or so, and then you could very easily just undo these rivets, or if you use a bolt, then you could lower it down and it would look good again. Now you have to cut around the corner, otherwise it won't bend up. But just that simple cut, and you can push this up and locate it anywhere you want. Now this trim line, don't forget, as you come down, don't keep trimming it, because you're going to get a hole here from we cut away the corner. So it has to come out right about to the corner, and then leave the rest of it here. Now also for cooling issues, there's now, with this curved setup here, an opening back in here, okay? And that could be closed from the inside with just a piece of sheet metal, because that way all the air will then go up into this and through the radiator. Of course, don't close it up initially. Fly the airplane. If you got plenty of cooling, don't worry about closing up little holes and stuff. If you need a little bit more cooling, close up all the holes, let all the air go through the radiator. This particular aircraft is a Kit Fox, and it has a panel layout that has been made in sections. It is a frame, and it has a large cutout over here. It also has a large cutout over here. This enables the builder to remove these cutouts, and by providing slack or service loops to the wiring behind, to lower these out of the aircraft for service at a later time. This happens to be a temporary panel for the layout of all the switches, and we will describe in short sequence here what is required on the panel to run the operate the Viking engine, and all those items are now in view of the video. As far as breakers, we need a 10 amp for fuel pump number 1 and a 10 amp for fuel pump number 2. Then the two first switches here are fuel pump switches. You can arrange in any order you would like that is better for yourself as far as cockpit management, but we have a fuel pump 1 and a fuel pump number 2. We also have these guarded, and you might want to put guards on all of these switches, but that is because if the fuel pump is on and you inadvertently shut it down in flight, the engine will shut down because there will be no more fuel pressure. The backup fuel pump, as we covered, battery 1, battery 2, and the ECU, or the engine computer. Now, let's run through that really quick again. We need a breaker for fuel pump 1, one for fuel pump 2. We need a switch, which is in the grab bag that Viking sells, for your fuel pump 1, one for fuel pump 2, turning on battery 1, turning on battery 2, and the computer selecting computer 1 or 2. This will be applicable through 2014, and then this particular switch will disappear on 2015 engines. In addition to those switches, we're going to need a starter switch, and the function of this starter switch is an off position, a alternator position to keep the alternator alive with its field wire, and then a start position where you have the spring-loaded part of the switch, and you're actually cranking the engine. Now we're going to take a look at the back side of this panel and explain what wires go where in order to make all this work. Filming the engine wiring bay of this airplane, we're zooming in here and we're finding the back of the panel that are housing the switches that run the engine, or that makes the engine do what you want it to do. We see the back of the ignition switch. It has 3 wires on it. One is the starter wire, which goes to the center. That wire goes directly through the firewall in our pass-through with the rest of the wires, and it ends up at the starter right here, and it is the wire that energizes the solenoid to make the engine crank when you turn the key to the spring-loaded position. There's another wire on here that's called ignition. The ignition wire is not used for the ignition. It is just labeled that way by the manufacturer of the key switch. It is actually controlling the alternator field in this airplane. And the reason for that is so that you can turn off the batteries during shutdown and then turn off the key completely, and the engine will then stop because you're cutting off the power that makes the alternator operate. And that's a test to make sure the airplane can run on the alternator. This wire is very simply hooked up to here, and it runs out through our wire bundle, and it goes across the engine, and it's protected in a little piece of loom, and then it runs down to where the alternator cable is, but it's actually attached to what we call the top of the T of the back of the alternator. That would be the, if the 2 terminals are here, they make a letter capital T, and this will be the top of it. And that needs to be installed securely because that is what is going to keep your alternator alive. As you can see, the alternator wiring here is all secured as it leaves the alternator, so there's no bending load on these terminals. And that's the second cable or wire coming off that. The third one is powering up the switch itself, and that is the battery terminal of it, and that just runs over to our positive bus in the airplane. And that explains the ignition switch and its routing of wires. Moving down below that, we have the 2 breakers that are powering the fuel pumps. What you want to do is bring a couple of wires from your positive bus organized to one side of your breakers. Then go from your breakers, the other end of the breaker, and loop a couple of wires over to one side of your fuel pump switches. And then from the output of those switches, bring some wires along your organized path, and then bring them down to the fuel pumps themselves, and put those on the positive terminals of the fuel pumps. If you zoom right in here, you can see that there is a positive marked on the pump in the plastic right here, and there's also a negative marked right here on this. It's very faint, but it's there to make sure to get that polarity correctly. Now, after you have the positive side of the pumps wired, bring another 2 wires, actually 3, because you also want one for your pressure transducer. Bring those back alongside with that wire bundle, and then just bring them to your negative bus of the engine. Don't ground them to the frame back there. Keep everything organized. Bring your wires all the way to the pump, and then bring them back for the grounding, and then label everything. We are using shrink tubing with the names of everything on it, and it makes it very easy for you or someone else to service your aircraft in the future. That covers the 2 fuel pump switches. Now, the battery switches are also simple. You have 2 switches. They're just single pole switches. Happens to be this one and this one. And those are wired very simply because in order to turn your batteries on or off, they're just grounding the solenoids, and there's a terminal on each solenoid for that purpose. So you do have to bring ground to those to close the contact and energize a battery or the other battery, or if you move both switches up, both batteries at the same time. Now, in order to get ground to those terminals, again, wire your negative bus, your grounding bus. Bring 2 grounds from there don't bring a single ground and then jump it between the switches. Everything is made to be redundant. Bring 2 separate grounds over to your switches, and then bring the wires back from your switches, and then one goes to battery contactor 1, and then one goes to battery contactor number 2. And that concludes the wiring of the few switches that are necessary to run the engine. Okay, we're going to pull our covers off of our positive and negative bus to show how that's all done. What we've got is the solenoids that we explained. We have a wire from the positive, and we showed how that goes to the primary, to the starter, and to the alternator over here. There's also another wire that you can see that runs here. It's a fairly heavy wire, and it powers up our positive bus for the engine. Well, we need that positive bus because we have a few wires that are necessary to keep the engine running. Those would be your fuel pump number 1 wire, your fuel pump number 2 wire. You would need a wire to power up the engine computer, and those are the 3 that are necessary for the engine. We continue on with the grounding bus. Very simple for the Viking engine. You do need to designate a grounding bus for the engine. As we showed before, in the grounding system over here on the firewall, you see we're teeing off with a very securely made cable, and we're bringing that over and into the large terminal on our grounding bus right here. That grounds the whole bus, and we now have a designated bus that we can use for the engine installation without clouding it up with other items for the aircraft, such as lighting and avionics. Those are other buses. We are focusing now on a separate system to securely wire and keeping organized the wiring of the Viking aircraft engine in this aircraft. Now, as we explained with the positive wires, there's very few that are needed to operate the engine, but there are some, and they are critical, so the wiring has to be done appropriately. What we have is the ground for one fuel pump and the ground for the other fuel pump. We also have on here a ground for contactor number 1, and right below it we have ground for contactor number 2. Okay, we're going to talk about battery installation. We're using the lithium-ion batteries, and they're mounted inside the aircraft because they're not recommended to have high temperature. We have them installed with a strap here, as you can see in the kit box, and we've made proper grounding cables from each battery. They're passing through the firewall. We made up secure pass-through studs for that on the inside as well as on the outside. And then from there we have a grounding cable running to 2 separate locations on the engine. Of course, the engine is what we're mostly concerned about grounding properly. So we have ground there with the proper terminal, proper bolt, and proper crimp, and a strain relief to that cable. We also have the other ground for dual redundancy in the grounding system all the way from the engine through the firewall and to the individual batteries. Being that the 2 batteries are now going directly to this stainless steel firewall, we do not need in this installation a jumper between the battery for further redundancy. They are in fact hooked together by being bolted to this stainless steel firewall. From that ground we also tee off with another ground right here, and this is the ground that powers all the things in the airplane as far as your lights and your avionics and your engine control system and all that. So that's the whole grounding system.